Assalamu alaikum. So the lesson today is about linear functions. So we are going to give an introduction to linear function. So but before let's talk about two variable linear equations. So what is a two variable linear equations and the type of solution of this kind of equations. So two variable linear equation. So two variable linear equations is an equations defined by ax plus by equals c, where a, b, and c are number and x, y are variables. So this is the type of two variable linear equations. Two variable linear equation is an equation, which means has the property of equation, is an equation defined by ax plus by equals c, where a, b, and c are numbers and x, y are the unknown. So example of give you an example of two variable linear equations. So for example 3x plus 4y equal minus 11, 4x plus 9 equal 2y. So let me use here plus 11, 11, and so on. So those are example of two variable linear equations. So the solution of this type of equations in fact is a set of ordered pair. So it's exactly what is the type of solution of that equation. So we don't have one solution or two or three, we have infinite of solution and we represent the solution as ordered pair. So the type of solution of this kind of equation is a collection of ordered pair. Is a collection of ordered pair. And those ordered pair satisfy the equations that we choose. So the set of solution is the collection of ordered pair, which is x, y, that satisfy these equations. So any x, y we choose, when you substitute here, it will give me c. So those are the variable. So I substitute the variable here if I pick a numbers. So we should get the same value of c for any change of x and y. So then we said that all the pair belongs to the solution. So let me give you an example, you will see the idea. So if I choose, for example, 2x minus 3y equal 4. So example. So I want to solve these equations. So solve uh, 2x minus 3y equal 4. So if you want to find out the solution of this, so as you will see, you will have not one solution, we will have a lot of solution. In fact, there's infinite of solution. For example, if I choose uh, x equal 2 and I choose y equals 0. So when I substitute 2 here and 0 here, I will get 2 times 2 minus 3 times 0. And this should give me 4. So 2 times 2 is 4, minus 0 is 4. So this is a solution. So I can say the order pair 2, 0 is a solution. For example, if I choose x equal minus 1 and I choose y equal minus 2. So I got 2 times minus 1 minus 2 times 3 times minus 2, 3 times minus 2. So normally I should get 4. So I have minus 2 here, and here we have minus 6, and minus become plus 6 here. So minus 2 plus 6 is 4. So as you see here, we have minus 1 minus 2 is a solution. So if I pick another example, so you will see that we have infinite of choice. So if I pick minus 7 and y equal minus 6, so I got 2 times minus 7 minus 3 times minus 6. So is it equal to 4? Let's check. So this is minus 14, minus 18, and minus become plus, so plus 18. So this is equal to 4. So I can say that minus 7 minus 6 is a solution. You see? I can pick another one. For example, if I pick uh, x equals 0 and y equal minus 4 third. So if I have 2 times 0 minus 3 times minus 4 third, is it equal to 4? So this is 0. Minus minus is positive, so we have 3 here and 3 here, so we cancel out. What's left is 4, so this is 4. So that's mean again 0 minus 4 third is a solution. As you see, we don't have only one solution, we have infinite of solution. So my set of solution here will be what? I just write down those. It's going to be this order pair, so it's going to be 2, 0, minus 1, minus 2, minus 7, minus 6, and we have again, I can have 5, 2 is a part of the solution, 0 minus 4 third. You see, we don't have 1 or 2, it's infinite. So we have infinite of solution. So the solution is a collection of order pair. And we defined the previous lesson when we learn about relational function that any set of order pair is a relation. That means this set of order pair, which is a solution of this type of equations, is a relation. But the thing is a relation with with an exception. What is the exception? All the x are not the same. All the x are distinct x. So which means it gives us the option not to call it only relation, but we can call it function. So the solution of this type of equations is a function. So if we choose to draw those solution in the coordinate plane, so for example, I want to draw those solution on the coordinate plane. So remember the solution we pick, we got s is 2, 0, minus 1, minus 2, minus 7, minus 6. We have 5, 2, and we have 0 and minus 4 third. So those, and we have more. So we try to graph this in the coordinate plane. So let's graph each point 0, 2, 2, 0, sorry. So 2, 0 is here. This is my 2, 0. Minus 1, minus 2. So this is minus 1, this is minus 2. Again, I have minus 7, minus 6. So minus 7, minus 6. 5, 2. So we have 5, 2. 0 minus 4 third, so which is minus 1 and third, so it's going to be somewhere here. Now let me try to connect those points. So if I pick a line, I want to draw a line here. As you see here, all the points belong to the same line. So if I extend my line, if I extend my line, you see, I will find out all the solution. I can find out all the solution if I extend my line. So those are all the solutions. So either I can, you see, for example, minus 10 and minus 8 is a solution. As you see here, you see this is a solution, minus 10 and minus 8. So if I plug in minus 10 minus 8 in my equation, so let me pull out the equation back here. So it's 2x minus 3y. So 2x, this is my equations. So 2x minus 3y equal 4. So if I choose x equal minus 10, so you see that point. So it's going to be 2 times minus 10 and minus 3 times minus 8. So it's minus 20. Minus minus is positive. 3 times 8 is 24. So it's going to be plus 24. And when we add, it's going to give me 4. And this is what we got. This means this is a part of solution. So all the points that belong to this line are part of the solution. So it's because this represents a function. So in a graph, it's a line. So that means this is what we call it linear function. So this, in fact, is a linear function. So the solution of that equation is a linear function. So the solution, so I'm going to write it in red. So the solution of 2x minus 3y equal 4 is a linear function. So let me repeat what did we say. So we see that the solution is a set of ordered pair. And in the lesson, which is the previous lesson when we talk about relation and function, we say that relation is a set of ordered pair. So this is a set of ordered pair, which is the solution of this one. So in fact, the set of ordered pair is a relation. But this relation has something different than the regular relation. What's the difference? Is each x is distinct from each other, which means it's not only a relation, it is a function. Now, when we graph this function in the coordinate plane, we find out that it has a shape of a line. You see, it has a shape of a line. So instead to call it just function, so we're gonna be more specific. We're gonna be more specific. So we're gonna call it by the name of the shape they create in a graph, which is linear function or line function. So this is exactly where the idea of the linear function come from. The linear function come from the solution of a two variable linear equation. So this is exactly what is the definition of linear function. Now let's talk about linear function now. So we're going to define what is linear function. So a linear function is the collection of solution of a two variable linear equations in the number set. So linear function is the collection of solution of two variable linear equations. L in the real number line or number set. So now instead to say this is my linear function, so we name this as linear function because this is the source of this set of order pair. So the source of the set of order pair, we're not going to call it anymore two variable linear equations. We are going to call it from now on linear function. So the source of those solution will be called linear function. And this notation will have a name which is the standard notation of linear function. So the standard notation of linear function is in fact ax plus by equals c, where a, b, and c are numbers. You see, the notation of a two variable equations become the linear function because it's the source of the set of order pair that define function. So it's exactly what is linear function, and this is the standard notation of linear function. So let me give you an example of linear function. It's like I'm giving you example of two variable linear equations. So I think you got the idea. So 7x plus y equal 11. So this is a linear function. 3x minus 4 equal to y, and so on. So any form of two variable linear equations is called from now on linear function. So now instead to have x, y are the variable, so the x and the y will have some rule. So the x value of the function will be called the independent variable, and the y value will be called the dependent variable. So this is the property. So the x value, so the x value in the function is called the independent variable. So now space here. So let me the independent variable, and the y is called the dependent variable. The y value in the function is called the dependent variable. There are other way to name those variable. Some book they call it input and output. So x value, it's mean input, and y value they call it output. So it's the same thing. That means the output depend on the input. So if I have an input, I get the output. If I don't have an input, I don't get the output. This is why y depend on x. And the notation we use for function, which is we learned last time. So the notation, so f of x is the same thing as y, and this f of x, it has a meaning. So f, that means the output. F is the output. So f of x is the output that depend on x. That depend on x. This is why when we have y equal, for example, mx plus b, and we say f of x equal mx plus b, which means this value is my y. So if I change this x will be affected. The m and the b, even though they are letters, but they're not variable. So f of x tell me that the only variable in this expression is x. If I wrote this mean here, the only variable is x. If I wrote, for example, f of b equal mx plus b, here the only variable is b. So here the only variable is b. What does it mean? If I change the value of b here, I will change only that b. Those for me, they're not variable, they are numbers. The same thing here. X is the only variable. If I change this x, I will change only that x. Those two stay fixed. For example, for the first question here, for the first statement here, if I do f of 2, I will have m times 2 plus b. You see, b and m didn't get affected by the change of x, because for us, it's mean the only thing can change is that x. If I choose again f of x over 4, so this will be what? M times x over 4 plus b. You see, I change this x by x over 4, so I change this x by x over 4. Whatever the form this x take, whatever the form this x take, this x will be affected. M and b, no. So the variable that you have here is the one that it's the independent. That means is the one who change. The rest don't get affected. So that's the idea behind this notation, and this is why most of the book they use f of x equal mx plus b to show you that which letter is the variable. If you have x is the variable, that means the x in that expression is the variable. If b is the variable, b in that expression is the variable. If I have m here, m in that expression will be the variable. I hope is clear. So for common notation in terms of order pair, so either sometimes we have x, y is the order pair, or we can have x, f of x. Those two are the same thing, because we already say that y is equal to f of x. Y, f of x is the same thing. So if I have, for example, let me give you an example. Suppose they give me this function, y equal 3x minus 5. The solution of this type of equations is the order pair xy. But if I don't want to use the y in my solution, I can say is the order pair x and I substitute y by this, which is 3x minus 5. Or you can say is x f of x, given that this is my f of x. So those are the different notation of the solution of this type of linear function. So now, in terms of graph, as you see in the beginning, so we say that the set of solution is a line. You see, the set of solution of the two variable equation is a line. That means the linear function in fact is a line. So, and a line has different shape. It may be a horizontal line, vertical line, or slant line. So we have three type of line. So and each type has its own equations. So let's talk about graph of linear function. So so the graph of every linear function, so let me name it ax plus by equals c, is a line, is just a line, is a line. Any linear function is a line. And there are three types of line. There are three types of lines. So the first line, so we have horizontal line, which means a line like this. So this means it's horizontal. And we can have this line only if I have the, well, let me put here my equations, ax plus by equals c. So we can have this line only if I have a is equal 0. So we have, we may have horizontal line if a equals 0, which means my equations will be, which is the equation of the line, so, and b not equal 0, of course. Well, this means the equations will be by equals c. So when we have by equals c, the shape of the line is a horizontal line, or y equal c over b, or a constant. So when we have y equal a constant, or we have by equals c, so it's a horizontal line. So let me give you an example of horizontal line. For example, y equal 3 to y equal minus 5, y over 7 equal minus 2, and so on. Even we can have y equals 0 is horizontal line. Y equals 0, which is most of the time is the x-axis. So keep in mind when you have y equals 0, it's mean the x-axis. So the second type is vertical line. So, and which is like this type of line. Let me put it here because I need some space. Like this is a vertical line. So when we have b equals 0 and a is not equal 0, so we will have a vertical line. So when a is not 0 and b equals 0, so in that case we will have ax equals c. So this is a vertical line. So either we have this or we have x equal a constant. So example, so let me give you an example. For example, I will have 4x equal 5, x equal minus 3, or x equals 0. So in that case, we call both y axis. So when we have x equals 0, it means the y axis. So in the graph, so this is x equals 0. This is y equals 0, is the x-axis. Just to keep in mind. Now, let me talk about the last type, which is called the slant line. slant line is when a and b are not equal 0. So it is when a is not 0. My equation is ax plus by equals c. So and b is not 0. So of course the equation will be ax plus by equals c. This is stay as it is. So example, and the slant line look like this. Either we have either like this or like this. Those are the two type of slant line you may have when you graph linear function. So example, so 2x plus 2y equal 5 and 3x minus 5y equals 0 and so on. So let me show you the graph of linear function, the tree graph. So let me raise this and give you an example how the graph look like. So in that case, you will have an idea. And next lesson we will show you how to graph a linear function. So all right. So okay, if you give me a moment, let me erase this. Right, sorry for that. Okay. All right. So if I, for example, y equal 5, so y equal 5, this is y equal 5. So here I will draw horizontal line. So this is y equal 5. For x equal minus 2, so this is minus 2, so I will draw a vertical line. And for slant lines, if I choose 2x minus 3y equal 6, so I will have this type of line. So it's gonna look like this. So it's gonna look like this. So this is the line. So for this one is y equal 5. Here is y equal minus 2. And this line is 2x minus 3y equals 6. Each time we draw a line, please name the line. So it's very important. So this arrow means that it keep going. So it's not gonna stop. So this is just an example how the line look like when you have those two type of lines. So in next lesson we will talk about how to graph a linear function, and we're gonna learn the different way how to graph it. So this is all about this introduction. So I hope you understand the idea and where the linear function come from. So thank you for watching the video, and if you have any comment that will help me improve my way of teaching, it's very welcome. Thank you for watching, and Assalamu alaikum.